This video covers absolute value inequalities. Go ahead and complete the warm-up problem and pause the video, and when you finish, go ahead and check your work. Check your work for the warm-up problem. You'll notice that you do get two solutions. However, when you go to check both of them, the negative 10/3 doesn't work. Absolute value inequalities. So what we're going to be looking at is an absolute value where you have a less than or greater than, or a less than or equal to, or greater than or equal to in the problem. The setups are very similar to regular absolute value equations. So what you'll see here is I have two identical setups, but I do have an equation on the left and a less than symbol on the right. So when I look at this left-hand side problem, I'm thinking about taking the 2x minus 1 and setting it equal to 5 and negative 5. So I'm going to go ahead and do the calculations for those. So we have 2x minus 1 equals 5, or 2x minus 1 equals negative 5, and then you'll solve both of those. So for the first one, we get 2x equals 6, or x equals 3. And for the second one, we're going to add negative 1 to both sides, so we'll get 2x equals negative 4, or x equals negative 2. So you have two solutions to this problem, and of course if you plot them on a graph, they're simply just points on a number line. So we've got 2, and this is actually a negative 2 right here. Let me go ahead and erase this. So 3 here, and negative 2, and then we have closed circles on our graph. Closed circles indicate solutions. Now let's go ahead and work out the same problem as an inequality. So what we do here is we think about breaking it into two inequalities, but we have to rewrite the 5 as a negative 5, and we also have to change the inequality symbol. So I have 2x minus 1 less than 5, and the second one is going to be 2x minus 1 greater than negative 5. Because we're changing the 5 to a negative, we also need to flip the inequality symbol. Now with inequalities, we have to decide if they're and or statements. And statements mean all values in between two solutions work, where or statements mean all values less than one of them and greater than another. So for this one, when I think about less than 5 but greater than negative 5, well, on a number line, less than 5 and greater than negative 5, when I plot those, less than 5 is going this direction to the left, and greater than negative 5 is going to the right. So they're overlapping values, which makes this an and statement. So I'm going to go ahead and put the word and in between both of these inequalities. I'm solving it identical to the equation set up on the left side. So I have 2x less than 6 and then x less than 3. So no different. And over here, I've got adding 1 to both sides, to 2x greater than negative 4, and divide both sides by 2, so you get x greater than negative 2. So I bring this and statement down. Now when you write an and statement, and you're going to write these together as one compound inequality, so what you do is you put the x in the center. On the left side we have x less than 3, so that means x is smaller than 3, but x is greater than negative 2. So notice I'm writing the numbers from the smallest value up to the largest with x in between. And statements are in between the two values. So when I graph this, I have negative 2 and 3 as my endpoints. Negative 2 and 3 are not solutions, so they are open circles, and x is between them. So you shade in between, and that's the algebraic representation as a compound inequality, as well as the graphical representation of the compound inequality. This next example, we're also solving and graphing an inequality, but this time we're going to do an example of an or statement. So I'm going to break this apart into two different inequalities, but this time I have to use greater than 15 or less than negative 15. So I'm going to go ahead and do the setups. And keep in mind that you're changing the 15 to a negative, and you're flipping the inequality as well. When I think about a number line, greater than 15 is larger and to the right, and less than negative 15 is going to the left from negative 15. So you can see that the solutions are in opposite directions. So that means that this is a or statement. So I'm going to go ahead and solve both of these. You get x greater than 1 for the first one. I have my negative onto this side. Divide both sides by 5 and you get x less than negative 25. So these are my two solutions, x greater than 1 or x less than negative 25. And that's how you write your solution as well. So graphically, I'm going to go ahead and put the two end values, 1 and negative 25. So let's see, I forgot to divide by 5 on both sides here, so let me fix that. That should be a negative 5. That'll change things a little bit. There we go. And greater than 1. So 1 is not a solution, but it is an endpoint. So all the solutions are to the right from 1 because they're greater than 1. And negative 5 is not a solution, but it is an endpoint to our solutions. And it's all less than values. So there is the algebraic representation of the solution and the graphical representation. For number 1 and number 2 here, you're going to want to isolate your absolute value before you work out the problems. I'd like you to go ahead and solve both of these problems, pause the video, and then come back and check your answers. Go ahead and check your two solutions for number 1 and number 2. Notice the first one is an AND statement. And when you get down to solving these separately, you'll notice that the 8 is larger than the 4. So when you write your compound inequality, the 4 should come before the 8 in the statement. And in number 2, just keep in mind that this one is an OR statement because greater than or equal to 2 and less than or equal to negative 2 actually initially go in opposite directions. So this is an OR statement as well. The last thing that I want to talk about is absolute value inequalities that are involving negatives. So notice that the right-hand side of the equation and both of the inequalities have negatives in them. If the absolute value is isolated, when you have a negative on the right-hand side, these particular cases occur. So when I look at this first example here, I'm using common sense. Is there any situation where I could take the absolute value of some value right here, anything you want, it could be anything in particular, will you ever get a negative result? That'll never happen because distance is always positive. So when I take a scenario like this, that's always going to be no solution. Now you can apply that common sense idea to the next two as well. So if I'm looking here, this is saying if you take the absolute value of anything, will you get a result that is bigger than negative 5? Well, when I take an absolute value, I'm always going to get a positive result. That will always be larger than negative 5. So for this particular one, I will always have solutions of all real numbers. You can say identity if you would prefer. I've seen that as well. Or identity. This last one here, so 2x minus 3 less than 5. So this is saying that if I take the absolute value of anything, will I ever get a result that's smaller than negative 5? Well, once again, this is impossible because I'm always going to get a result that's positive on the left-hand side. So in this case, you're going to put, whoops, no solution.